This chapter explains about the symbols regarding interference suppression and cable screening. Depending upon the type of signal passing down a cable, interference can occur. For protection, certain cables, those joined to speed sensors for example, include a flexible metal shielding or screening that surrounds the main core. It offers two-way protection by resisting spurious signals getting into the cable and preventing interference-type signals from getting out. To be effective, the shielding is connected to ground at some point. This symbol denotes screened cables that are connected to ground via the control unit. Here's an example of what it looks like in reality. To which component are the cables connected? Register your answer by clicking on the component in the legend. You can use the navigation tool to move around. Yes, that's correct. Well done. This symbol indicates screened cables that are connected to a separate ground point, W7. To which component are the cables connected? Click on the component title in the legend. Yes, that's correct. Well done. This symbol indicates twisted cables. Twisting the positive and negative cables of a component around each other offers an effective way of preventing interference. It results in the two opposing magnetic fields created by the signals in each of the cables being cancelled out. The technique is used in several areas of the vehicle wiring. To which component are the twisted cables connected in this example? Click on the component title in the legend. Yes, that's correct. Well done. This symbol, which is identical to that on the adjacent cables, also indicates twisted cables. Twisting the two cables together cancels out any interference caused by electromagnetic forces. If you note the two connector sleeves J142 and J143, and then refer to the legend, you'll see that the two cables are part of the CAN system. Using twisted cables in a CAN system is particularly important to guard against spurious signals being received by the control units. Following the cables down the diagram, you'll find that they continue on another diagram for the CAN bus system. This is an example of a CAN wiring diagram for a Mercedes-Benz Vito. The CAN system is a two-cable system that communicates digital messages bidirectionally between the different control modules. The system transmits data at high speed and helps to reduce the number of electrical cables by transmitting different messages along the same two cables. The two cables are known as CAN low and CAN high. Two identical signals are transmitted down both cables simultaneously, but are inverted to each other to reduce the risk of interference. The separate connector sleeves J142, CAN high, and J143, CAN low, join together the CAN cables from each control module. The diagram is a schematic view of the complete system, and therefore only includes the terminals of the control modules that are connected to the CAN cables. The module's remaining connections are shown in the applicable system wiring diagrams. Study the diagram and identify the control module. Then go to the CAN bus diagram using the navigation tool and click on the correct symbol for the control module. Yes, that's correct. Well done. This diagram shows the complete CAN network and control modules for a Mercedes-Benz Vito vehicle. However, depending upon the vehicle's specification, only some control modules may be installed. We want you to identify the control modules that should be fitted in a Vito vehicle equipped with CDI engine, air conditioning, immobilizer, and anti-lock brakes. Click only on the modules that are correct for the vehicle. Yes, that's correct. Well done. The virtual diagram will allow you to explore freely the lighting, interference suppression and CAN circuits. You'll be able to revise the circuits for the license plate lights and the right-hand low beam headlight. In addition, the symbols for interference suppression can be reviewed. The circuits pass through components such as the combination switch, electrical center, rear door contact switch and the right-hand headlight. You can navigate around the diagrams as you like and click on any of the highlighted components to receive an explanation. The navigation tool will help you to move around. The terminal designations 58L and 58R, which are common throughout all Mercedes-Benz wiring diagrams, supply the left and right-hand side and tail light circuits. The L and R stand for left and right. K supplies the license plate lights. Fuses F12 and F13 are supplied from 56 of the lighting switch. The 56 signifies a connection to the headlight circuit. This is the input terminal to the lighting switch, which receives the battery supply. Terminal designation 30 denotes battery live. This circuit line supplies battery voltage to the switch contacts of non-post vehicles. This is the lighting part of the combination switch. The complete combination switch, which includes functions such as wipers, indicators and lights, has a designation of S2. Therefore, each individual switch has a prefix of S2, followed by an additional small s and a number. For example, the lighting switch is S2, S2.